Unit 2, equation, day 5. Today we are doing two-step equations. But the key to today is I kind of want to scare you a little bit. Let me show you what we're going to do. If you want to copy down what I'm going to do, that's fine. But it's not necessarily the point. I'm going to show you a tough equation that I would expect you to know by the end of what we do. And then we're going to go from there. So I'm going to make something up, and it might end up being a fraction. But this is going to allow me to show you what the steps are, which is why we want this other anchor chart. Because the steps will stay the same for almost every single equation. So step 1 will always be the same. The first step will be to find that balance point. Does everybody agree that that equal sign is the balance point? Okay. We have two sides now to our equation. Does everybody agree with that? We've got a left side. We've got a right side. We're no longer worried about this equal sign. We're only worried about the left side and the right side. That means there is an expression on the left side. There's expressions on the right side. Everybody agree? Okay. So step number 2 is going to be distribute on each individual side, if needed. The key is if needed. Do I need to distribute on this side? Yeah. I'm going to take this 3 and I'm going to distribute it to the x and to the -7. That gives me 3x minus 21 plus 2x. So we're distributing if needed. We're only focused on one side. Okay? I don't care about this side yet. I'm still dealing just with the left-hand side. The next step after distribute if needed, combine like terms on the same side if needed. So on the same side, what are my like terms over here? I need hands. What are my like terms over here? Swill?
3x and 2x. Oh, positive.
Thank you. 3x and positive 2x. That gives me 5x minus 21. Is there anything else I can do to this left side? No. Then we're done with that side for now. So now we go back up. We say, can we distribute? Is it needed? Yeah, I need to distribute this -4 to the x, -4 to the -8. That gives me -4x plus 32, up positive 7 to the 2x. That's positive 14x, positive 7 to the -3, that's -21. So distribute if needed, did it. The next step says combine like terms on the same side if needed. Are there like terms for me to combine? We're just focused over here. Are there like terms?
Yes.
Evan, what are they?
-4x and positive 14x.
Good, which gives me, hey, you're on camera, don't screw it up.
Okay.
Oh man.
10x.
Good.
10x, yeah.
10x. Then I've got this positive 32 minus 21, which gives me a positive 11. Is there anything else that I can do on this side? Again, is this what you're solving today? No, but this is how we're going to build our rules. So now I've got this problem here. 5x minus 21 equals 10x plus 11. Does that look a little less scary now?
Yeah.
A little bit. We're just whittling our way down. But now we have to look at the whole thing. Notice I didn't bring an equal sign down until I couldn't do anything on the left side. I couldn't do anything on the right side. Now we need to combine like terms on opposite sides using what? What kind of operations are we going to use if we want to combine like terms on opposite sides? What's that term called? Jackson? What kind of operations? Yeah, we're going to add, we're going to subtract, we're going to multiply, divide. But when we move it from one side to the other, inverse operations. B, thank you. Making me look good on the video. Good job, B. Inverse operations. So, I want to get all of my x's to one side. Get all of the x's away from me. Don't watch that, darling. Get all the x's away from me. So, we need to move this positive 5x to the other side. What am I going to do to the positive 5x? What's the inverse of plus 5x? David?
Inverse of plus 5x.
Mm-hmm.
Minus 5x?
Yeah, so I'm combining like terms on opposite sides using inverse operations. So negative 21 drops down equals 5x plus 11. Still with me? Are we done? No, because I still have an 11 and a negative 21. We can combine those. So I need to move a positive 11 to the other side, minus 11. That gives me 5x equals negative 32. The last step always is isolate the variable. We isolate the variable. How? How do I get the variable by itself in this part now? I need more hands than this. I need more hands. Come on, I need somebody who hasn't done something yet. Come on, Brooklyn, how do I get rid of 5 times x? 5 times x. Divide by 5. That's going to end up giving me x equals, I can't simplify this, so it's going to stay as negative 32 fifths. But we've now put together a whole list of rules that we will use. Okay? So, this is about as tough as it's going to get. Here's our rules. Find the balance point. I would put this in my notes. If needed, distribute on one side. Step 3, combine like terms on the same side, only if needed. These 2 steps are if needed, because you're not going to always have to do that. Go to the other side of the equation, repeat steps 2 and 3. Step 5, combine like terms on opposite sides using the inverse operations. And 6 is isolate the variable. Mrs. Armstrong's writing is so nice.
We'll leave this up in class too. I mean, I would have these notes because if you go home,
Yeah, you're going to want these.
you're gonna want this. But we'll leave this up as a reminder for you to use as a resource. Okay.
Okay, so that was a lot of talking for a problem that you're not going to have to solve for a while. I was impressed. Most of you were able to walk your way through it and at least help me with that problem. Now, let's talk about going backwards now. We're dealing with 2-step equations. So, how many steps should I have? 2, right? Let's see some basic 2-step equations. 3x minus 8 equals 12. And I want you to get in the habit of following these rules. So you're going to hear me talking about these rules over and over and over, even though today we're not going to use 2 and 3 at all. Well, we're not going to use 2 at all, or 3 at all. Maya.
Is it supposed to say same?
Where?
Well, it looks like sane, but
It is same, yes.
Okay, it says same.
Oh, Mrs. Armstrong, making things sane.
they're on the sane side. It means they're not crazy. They're sane.
First step, find the balance
I
point.
don't know how to make them.
Actually, are we still copying this down?
Yes.
Okay, I'll give you a minute. Go ahead and copy that down.
Is that a better M?
Yes, ma'am.
Yes.
I like it.
Look at the entire M.
You're going to want those rules in there. So I'd put rules for equations or steps for equations, whatever you think you're going to need. Because are they rules that are 100% true? No. 99%? Yeah, they're going to work.
So, how can you problem solve if we can't see it? Yeah, then you can, you have freedom to get up and do it. That's fine.
Mm-hmm.
Sure.
No, you're not going to be able to do it. Okay, so for the most part, we're pretty caught up. If not, just leave a couple blanks, keep on going, because this isn't going to be hard. Here's my equation. How do I know it's an equation? That's my first. Be what?
Has an equal.
Has an equal sign. An equation. As soon as you see that equal sign, it's an equation. Find your balance point. Okay. Start on one side. It does not matter. I'm going to look at my right side. Step 2, distribute if needed. Anything to distribute? No. Step 3, combine like terms if needed. No. Step 4, repeat steps 2 and 3 for the other side. Is there distributing? No. No, there's no parentheses to distribute. Is there combining like terms? Can I combine a 3x with a minus 8? No. Okay. So now we're down to step 5, which says combine like terms on opposite sides. So I'm going to ask a question. What's the goal of any equation? The goal of any equation. Isolate the variable. We want how many x's? 1. So we need this x to become by itself. Everybody agree? But step 5 says combine like terms on opposite sides. If I gave you the problem, -8 minus 12, could you combine those? Are those like terms? Yeah, they're just numbers, right? We call those constants. So now I have a constant of a -8 and I have a constant of a positive 12. Oh, man, that was bad, Mr. H. Hold on. We're going to change this 12 to 3 to make it easier on you. Sorry, I know, I'm a jerk. Make it a 3.
What?
Make it a 3! That's what? Let's say what? Okay, so we've got constants on both sides of the equation. How can I move, because we want to isolate this, how can I move my -8 to the other side? What am I going to use? Evan?
You're going to use addition.
I am going to use addition. What do we call that? Megan? Inverse operations. So I'm going to use the inverse operation of addition. I'm going to add 8 to this side. When I add 8, -8 plus 8, that's the additive identity property, which is what? What's -8 plus 8? 0. So this is now 0. What drops down is my 3x. So again, always go back to that example of I've got a seesaw. I've now added 8 pounds to one side. What do I have to do to keep it balanced?
Add 8 pounds to the other side.
Yeah, add 8 pounds to the other side. So now I've combined like terms. Everybody with me there? I've got 13 plus 8. Simone, what's 13 plus 8?
21.
Right?
Which one? You can't give me like 4 answers and say
21.
21. Good. Okay, so we're here. Everybody still with me? Last step. Isolate the variable. How many variables do we want, Caleb? One what? But in this case, one what variable?
X.
1x. So we want this 1x right here, right? Everybody with me? 3 times x. What is the inverse? Go ahead, Maddie.
Division.
Very good. What am I going to divide by?
By 21. 21 by 3.
Yeah. So we're going to take this 3 and divide it by 3. Why does this work? 3 divided by 3 is what? 1. That leaves me with 1 what? X. We've isolated our variable. 21 divided by 3 leaves me with a... If you follow the rules and you keep asking yourself the question, it will go step by step by step and it will not be a problem. Can we do another one? Okay. Let's go 4 plus x over 3 equals -12. A little bit trickier. I want you to try the first couple steps. So see what you can do for example 2. Let me know what you come up with. Show me your work. Follow the rules. Go from there. And if you need help, raise your hand. seeing a lot of things. Okay, so most of us had at least the first two steps. I'm going to pick on Jackson. Jackson said, nope, don't need you, Mr. H. I got this. Jackson, walk me through it. Be the teacher. I'd have you up, but okay, good. Go ahead.
So what I did was take the 4 and well, first I found the balance
Oh, you found the balance point. Okay. Where's the balance point?
on the equal sign.
On the equal sign. Okay.
And then I subtracted the 4 since it was a positive 4.
Okay. Why are you doing that?
Because
Which step is that?
combine like terms on opposite sides.
Good. So you're taking 4 away from this side. What operation is that? That's the
The inverse operation.
very good inverse operation. So you do it to this side. What else?
And then subtract 4 from 12, which then you get negative 16.
Okay, let's stop right there for a second. 4 minus 4 is 0. All of this comes down. Notice, just like in combining like terms, it wasn't just the number, it was the sign and the number. So I'm bringing down a positive x over 3. Does everybody agree with that? Favorite mistake? Mrs. Armstrong, I bet you know what the favorite mistake was. As we came around, negative 12 minus 4, and I got lots of negative 8s. No. If you need to, think about money. If you lose $12 and you lose 4 more, are you back to $8 that you lost? No, you're losing more money. Okay? So, the way that I've taught you is, hey, forget the signs, add them up, 12 plus 4 is 16, keep the sign back on. Inverse, because we have division. So we need to use the inverse operation of multiplication. What's the inverse? Let me try this again. What's the inverse of division? Multiplication. And Jackson did. He multiplied both sides by 3. That left him with 1x equals. If you have to come off to this side to do this, that's fine. 3 times 6 is 18, carry the 1. 3 times 1 is 3, plus 1 is 4. Is it 4? Is this the answer right there?
Negative.
Because it's negative 16, it has to be negative 48. Questions?
Mr. H, I have a question for you.
Yes, ma'am.
So, why can't I just go ahead and multiply by 3 first to get the x below?
When we are doing equations, you can't multiply, you can't isolate the variable first. You have to combine those like terms first. It's doing the reverse order of operations. Have to keep everything with that x until the very last step. Everybody hear that? Okay,
So
let's
the
try.
x is last, or the variable is the very last thing you do. So if you look at step 6 up on the board, that's the first time you're going to see variable. That's the very last thing you look at. Okay?
We're going to do 2 more examples, and then you're going to be on your own. Try it. Go. So 5 minus x equals 7. Give it a try.
This one's a little tricky. Make sure you remember that there's always a coefficient in front of the variable. Can't just be negative x, and we can't end up with our variable blah, 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 blah. you cannot end up with your variable being negative. Okay, so you're gonna have to do something there at the very end. All right, how many more minutes do you need to solve this one? 1, 2, 3. Everybody good? You need 1 more minute, put a 1 above your head so I can see that you need more time before we solve this. Okay, so we'll take about another minute or so. Go ahead and work through it. If you have a question, raise your hand. I just had someone ask a really good question. We will come around and help if you have questions on this. Please do. Okay?
Thank you.
So you're subtracting and subtracting. So what do you get over here? So put it down. So what is on this side of the equation? Okay, can you have a negative variable? Every time.
Okay, so back to me.
What do you do?
Step 1, find the balance point. Easy. Step 2, distribute if needed, nothing to distribute. Step 3, combine like terms on the same side. We can't. Step 4, repeat for the other side. Yeah. Great. Step 5. Maya?
You can put a 1, right?
Where?
Between the negative and the x.
Maya, I love that you said that. Maya said, Mr. H, your rules don't mean anything until I put a negative 1x. I love that. If you just have a negative x, how many x's do we want? A negative 1 or a positive 1?
Positive.
Oh, so we've got a problem. Maya, that's fantastic. So now, we have to combine like terms on opposite sides. We've got a 7, which is a constant. We've got a 5, which is a constant. We need to combine those. Bianca, is my 5 positive or negative? So how do I move a plus 5 to the other side?
You subtract.
Very good. Subtracting is my inverse operation. 5 minus 5. 7 minus 5 is 2. Now watch what I'm going to do. Just like in the last problem, I circle my term, my x term, with the sign. So now I have negative 1x equals 2. What happens when we have a number right smack dab up against the variable? What does that mean?
Is multiplied.
Multiplication. How do we get rid of multiplication?
Division.
Division. I'm going to divide by a negative 1. Why? Negative divided by a negative is positive. 1 divided by 1 is 1. Which leaves me with a positive 1x. But I divided by negative 1 on this side. I divide negative 1 on this side. 2 divided by negative 1 is a negative 2. Show of hands. Thumb up, thumb down. Thumbs up for if you got it. Thumbs down for, oh my goodness. You have 2, what do you do? You're holding up a peace sign. That's nothing. That was not a thumbs up or a thumbs down. I don't know what to do with that. Okay.
Mr. H, the favorite mistake I saw
Mm-hmm.
is that somehow the negative sign disappeared when we brought x down. All of a sudden x became a positive and it was x equals 2.
Right.
So,
Notice the circle. Notice the circle. Folks, I'm not doing that for my own good. I want you to circle the sign and the number with the variable. That way you bring everything down.
so Mr. H, if I can make
Yes.
an assumption here. So when we're, just like when we were combining like terms, just like when we were distributing, we keep the sign,
Yes, ma'am.
okay? It's the same procedure, it's the same operation, you keep the sign.
Okay, last one. Then you'll get your practice problems, and we'll go from there.
If you have a question, raise your hands. We can't raise your minds.
Oh, man,
Okay.
if I could, it'd be funny.
It's probably a good thing we can't. That's a good thing. But raise your hands if you have a question. I don't want to read your minds. I want you to read mine.
Okay, so I got a couple favorite mistakes here too. So first off, start by finding the balance point. That's the easy part. I'm going to immediately circle whatever my term is with my x. It's a negative x over 2. Does everybody agree with that? Okay, so I need to move this negative 3 because this is a constant. This is a constant. They're on opposite sides, so we're going to use inverse operations. The inverse of negative 3 is what, Carly? Positive 3, because that's the additive inverse property. Negative 3 plus 3 is 0. So all of this, again, the circle, all comes down. 7 plus 3 is 10. X over, where does this negative, where should the negative go?
2.
With the 2. So now I have a division problem. How can I isolate that x to get 1x, Maya?
Multiplication.
Okay, what am I going to multiply by?
Negative 2
Yeah,
on both sides.
on both, very good. I'm going to multiply by a negative 2 on both sides. I saw a lot of people trying to multiply by a positive 2. That won't work. We've got to get rid of that negative because we want a positive 1x. Negative divided by a negative is positive. 2 divided by 2 is 1x. 10 times negative 2 is negative 20. Questions?